Okay, I have started the recording. I hope my screen is also visible to you guys. Is it visible? Okay then. Okay then, let's get it started. We have an option to allow let the people in. You can do that. Okay, let us go and see what we are going to discuss today. Okay, so look at this. So when I was talking about the relationships in Java, I said there are three kinds of relationship. If you remember or not, I'm not sure. I have started by saying that in Java, the relationship is possible in three ways. Yes or no? Let us allow the people in. Okay. Okay. The relationship is possible in how many ways? The relationship in Java is possible in three ways. So as a relationship is there as well as is a relationship. Okay. This talks about what? It talks about inheritance, right? Inheritance. And today we are going to discuss about the uses a relationship. Okay. So when I say uses a relationship, is going to talk about the concept of polymorphism. Okay, it is one of the important features in object oriented programming. One of the important features in object oriented programming. So we will see what is the polymorphism. What is the polymorphism in Java, right? So these are the notes that we have discussed so far on top of each and every topic. Let me scroll down completely. Okay, okay, the new topic, guys, polymorphism. Okay, so polymorphism, okay, this is one of the important features in object oriented programming. So I can say that people are just joining in. Let me let them in. Okay, I can just say that polymorphism can be defined as like poly means many. Poly means, what does it actually mean? Poly means many. And okay, let me do this in the double quotes. The word poly means many in the Greek. In the Greek language, the word poly means many, and the word morphs means morphs, right? So actually, the complete meaning of polymorphism is many forms. So if one thing is existed in many forms, we call it as what? Polymorphism, according to the object-oriented programming. Okay, one thing can be existed in multiple forms. Okay, if I want to convert this into a real-time analogy, I can say it like, okay, let me take a person. Okay, okay, I have a person. Okay, this is a person. So we are discussing about what? We are discussing about polymorphism, right? So poly means many forms. Polymorphism. Okay, this is our concept. Okay, so in the real world entity, if I ever had to make you understand about the definition of the polymorphism in the real world entity, I can say it, I can take a person. Okay, just imagine that this is myself. Okay, this is myself. Okay, so my identity is unique. Okay, my name is unique. Do you agree with or not? My name is going to be unique always. But if I go to office, okay, if I go to office, even though my name is Balaji, but my identity over there in my office, my identity is going to be what? Employee. I am an employee in an office. Likewise, if I go to the railway station, my identity is going to become as what? A passenger. I am one of the passengers. Right? So if I go to apart from office, if I go to my home, I am a son. I'm a son to my parents. So my identity is getting changed depending upon the place that I chose. Right? If I go to a restaurant, I become what? I become customer. I become customer, right? And if I go to any entertainment place, okay, if I go to what we call it as so I mean, I think I have covered almost all the things. I can choose many different places. If I go to stadium, or if I go to cricket stadium, I can be a supporter, right? If I start a business, I am an entrepreneur, or I can say it like I am an entrepreneur, right? So I am usually, my name is identified as Balaji. I am being Balaji. My name is always fixed, okay? But my identity is getting changed, depends upon the places that I choose. Okay, I become an employee in my office. I am a passenger in the railway station. I am a son to my parents. I'm an entrepreneur, to my business. I am a supporter when I go to stadium. I am a customer when I visit restaurant. Okay, so myself can be identified in many ways depending upon the places that I choose, depending upon the environment that I choose. Yes or no? Yes or no? This, I can say that Balaji has many forms. Balaji has many forms. What does it really mean? When I say Balaji has many forms, it doesn't mean that, it doesn't mean like this Balaji, this particular person. Okay, you cannot say it like, okay, I have these many forms. This is not the case. This is not the case. When I say Balaji has many forms, it's not the case. My identity is in many forms. My identity. I am the same person, but the places that I visit is giving me a specific identity. Right? This is what we call it as what? Polymorphism. Even in Java, you will find a situation. You will find a situation where you will find a particular function behaves differently in different places. Right? This is the direct example of polymorphism. Here, I have demonstrated myself about the word polymorphism. Okay, if I want to convert this into the Java language, I can say that simply this is the definition of the Java language. Okay, poly means many forms. So poly means many, morphs means form. So it means what? Polymorphism. Polymorphism. Right? So, and again, the polymorphism is categorized into two types. One is compile time polymorphism, and the second one is what? The runtime polymorphism. So, why do we require this compile time polymorphism? Why this many? Why this many kind of subcategories are there? Why this many subsets are there? We will understand each and everything. Okay. Next thing is the polymorphism. Okay, the polymorphism is categorized into two types. Okay, forgiving my spelling, it happens every time. Okay, let us do the spell check. Categorized into two types. One is what? The compile time polymorphism. Compile time polymorphism. And the second one is runtime polymorphism. Okay, let us understand this in the diagrammatical representation. Okay, when I say polymorphism, okay, let us use this space here. Okay, so this polymorphism is categorized into how many types? Is categorized into two types. Okay, one of the types are the compile time polymorphism. Compile time polymorphism, right? And the second one is the runtime polymorphism. We will discuss each and every polymorphism in detail. Okay, the second one is runtime polymorphism. Runtime polymorphism, right? And again, this under compile, it is not compiler, it is compile time polymorphism. Okay? This compile time polymorphism. Let me remove this. Okay? And again, come in the compile time, under the category of compile time polymorphism, we have two things, guys. We have very important things here under compile time polymorphism. We have method overloading, and we do have operator overloading. Under runtime polymorphism, we have only one subset, which is called as what? Method overriding. Okay? So you can conclude about the polymorphism when you learn about the categories as well as the subcategories. Okay, these are the under compile time polymorphism, it has been categorized into two types. One is method overloading, second one is operator overloading. Under runtime polymorphism, we have only one category, which is called as what? Method overriding. Okay, this is how it looks like, right? And please be informed that we have already discussed about this runtime polymorphism. I mean, this especially about this operator overloading. This topic has already been covered. People who did not attend this topic, I will provide you the link in the description, so you can repeat that once again. Okay, we are going to clearly discuss about this method overloading and the method overriding, right? So can we proceed, everyone? Type S in the chat box. So this is just an introduction. Okay, I will give you the complete explanation about each and every polymorphism. I want everyone to type S in the chat box so that I will be, yeah, good. So I will ensure that the session is going to be very interactive. Okay, so now let us understand what is this compile time polymorphism. I have just mentioned that there is a polymorphism called as what? Compile time polymorphism. What does it really mean? Okay. Before even understanding this compile time polymorphism, I want to introduce a small program. I want to introduce what? I want to introduce a small program. Not a program. I want to introduce something about this method signature. Very important word. What is it? The method signature. Okay. What does this method signature mean? We will understand now. Okay. Let me take this code. I have a class called as, I have a test class. Okay, inside this test class, I want to take two methods. Okay, the name of the first method is public void, okay, m1. Okay, and the name of the second method is public void m2. Very simple, very straightforward. I have one class. Inside this one class, I just placed two methods. Okay, one of the methods are what? Public void m1, and the second method is public void m2. We are going to understand what does it mean to be a method signature. Okay, the method signature is nothing but the name of the method. For example, let me take a parameter here, integer I am taking. Any random parameters I want to take to understand this topic full-fledgedly. Okay. When I ask you about the method name, if I ask you about the name of the method, so I am just highlighting this. If I ask you about the name of the method, you would say what? Sir, the name of the method is m1, right? If I highlight this and if I ask you about the name of the method, you would say what? You would say name of the method is m2, sir. Likewise, if I highlight this and if I ask you about the return type of the method, you would say void. Okay, if I highlight this and if I ask you about the name of the method, you would say name of the method is main. We know this, but we want to understand what is method signature. Method signature is combination of the method name and the arguments, right? These two things, method name along with the arguments that you pass, is called as what? The method signature. Okay, I am highlighting this to you. If I ask you what is the method signature of this method, what you have to say? This m2, combination of m2 and the parameters, these are the method signature that you have to say, right? This part is talking about what? Method signature. So don't you think that by using this method signature, I have the control to call the respective methods, yes or no? For example, let me take it as system.out.println. Okay, and I also want to take, something here like int argument, and I also want to take here something like what? Float argument. any random message I want to print. Okay, so it is not a rocket science logic. So I want to print something so that we will get to know which method is getting executed. Okay, that's my intention. Okay, now focus here. I said this is a method signature and this is a method signature, combination of method name and the parameters that you pass. Right, for example, if this method has two parameters, for example, the first parameter is integer I, the second parameter is integer j. Okay, this method has two parameters. You can keep any number of parameters, but the combination of method name and the parameter is called as what? Method signature. So we can call it as one method signature, and we can also call it as this one as a method signature. Okay, what actually happens? Okay, when you compile this code, what really happens? The compiler is going to create a method table. Okay, sir, what is a method table now? You are hearing this word for the first time, method table. What does it really mean? Okay, now see, I want to keep a logic here. This test obj equal to new test. Okay, you as a developer, you know that you know what you are doing. You are creating an object, and you as a developer, you want to call the respective methods by using this reference. Okay, you can now you have an option to call these two methods, obj.m1. Okay, and when I say m1, this is incomplete. Like a method signature is incomplete. You need to fulfill some, you need to send a value here so that the respective method signature gets respective method signature gets identified. Are you getting this? So m1, I want to call m1. I cannot simply call m1 like this, guys. I need to pass something. Okay, something as 100 here, because there is a method in the test class, okay, by the name of m1, which is accepting integer as an argument. Okay, so this is called as you need to map the value in such a way that the respective method signature is getting identified, right? Likewise, obj dot m2, okay, I need to do the mapping in such way that the respective method signature is identified. How to ensure that the mapping is correctly done? I'm using m2. This is not even a what we call it as this is not even the right solution. Okay, not even fulfilled. So to fulfill the exact method signature, I need to see what method name is valid. Okay, you need to pass some values that is of integer type and integer type. Any values, any random values, 10, 10. That is going to satisfy this. Okay, let us change this to double int argument. Double int. Okay, now the moment I run this code, let us do the execution. Okay, now Java C space test.java compilation. I'm sorry, I need to change the path. CD space Java 3 is the folder. Okay, now I hope it is visible to you. Java C space test.java space test. So we have an output like int argument and double argument. Okay, the respective methods are getting executed. Because of what? Because of the compiler is going to create something like a method table behind the scenes. Okay, let us go to this. Let us go here. Okay, and so I want to do what? Okay, this is our problem. This is our code. Okay, so let us reduce the spaces. Right. So this is our code. Okay, so we need to do the compilation. Okay, compiler will come into the picture. We know these things already. So compiler is going to do what? Okay, while performing the compilation, it is also going to do one more thing. What is it? That is going to create a table kind of thing. Okay, this is the compiler. Okay, it is going to create a table. Okay, this table is called as what? The method table. So I have just introduced about this method table just because we want to, it needs to be introduced as part of polymorphism. Okay, method table is something like it is going to store all the methods of the respective class with the signatures. Okay, now what is the first statement inside this object is getting created? Good. Okay, This obj is of what type? This obj is a reference variable of what type? This obj is a reference variable of test type. Yes or no? Of test type. Okay. Now what happens? It will identify, compiler will identify what? I mean all the methods. This one method and this is another method. Compiler will identify all the methods and it will store their method signatures, not the actual method. It is going to store what? The method table is going to store only the method signatures. Okay, what is the method signature? Okay, this is one method. So the method signature is m1. Okay, just int. It is not going to even consider this I. I is just a variable. It can be any name. Okay, it will store only the data type int, right? And what is the second method that we have? We have method name as m2 and it is accepting two arguments. The two arguments are of what type? Integer type. No value, I mean variable name will not be stored. Variable name can be anything. Okay. The method table is going to store all the method signature of the respective class. Okay, I hope you are understanding what is a method signature, and by using this method signature it will identify. Okay, Balaji is trying to create an object. Okay, object has been created, no issues, and this is going to get a reference, no issues. So far no issues. What is it? Obj, right? And Balaji is trying to call the method names m1.100, m1.100. It will try to identify if there is any method signature with the matching, with this matching statement. Okay, there is a method, there is a match here, okay, this gets executed. So m1.integer, okay, it is a match, the respective method will get executed. Likewise, what is the second statement? What is the second method called? obj.m2 10,10. It will identify the respective method signature inside the method table. Is there any method, such method which is accepting two arguments, two integer values as an arguments? Yes, there is a method identified, so the respective method will be executed. So this is all about, we are discussing just about what is a method signature, because if you understand method signature, then understanding the overriding concept, method compile time polymorphism, is going to be easy. Have we understood what is a method signature and why it is required for the compiler? Why it is required for the compiler to store the method signature in the method table, just to do the respective method calls. These things are done during the compilation time itself, right? These things are created during the compilation time itself, so that during the runtime the execution will be smooth and concise. Are you getting this? What is a method signature? Yes, no, everyone, right? Now see my definition. I can write something in this definition. The combination of, okay, method signature, it is combination of method name along with the method arguments. It is used by the compiler to create the method table, and the respective method signatures will be stored inside it. Making sense? And so that the method calls will become easy and get executed smoothly in the runtime. Okay, this is all about the method signature, and we will understand the importance of this method signature in the compile time polymorphism concepts, right? In the form of in the compile time polymorphism concepts. Now you see guys, so many people are going to get this doubt. Okay, when I say method signature, you are able to identify this as a method signature, right? Yes or no? you are able to identify the respective method signature. Now you see, now I want to do a small modification here. Okay, I want to do a what? I want to do a small modification here. Here I am taking integer I. Here also I am taking integer I. Okay, here instead of void I am taking a return type as integer. Right, and since this is an integer, I want to print something in the console. I mean, it has to. I am passing some value return, so that this method will be completed. Okay. If I ask you, is there any duplicate method signature here? Yes or no? What would be your answer? Okay, my question is, hey guys, can you identify any method signature duplicated here? Can you identify the method signatures are duplicated? What would be your answer? What would be your answer now? Duplicated or not duplicated? Don't you think that? So M1I same method signature, right? M1I same. I mean M1I is a different one. This is the method name is M2 and this is I, integer I. Both are different. There is no duplication. But when I do this, when I say the method as M1, okay, both method names are same and both methods are accepting the integer as the argument. It means there is a duplication. No matter if the return type is void or int, it doesn't matter. Okay, method signature always talks about this part. Okay, by looking at this program, you should be in a position to identify if there is any method signature duplication. Yes, there is a method signature duplication. Where is it? You can able to see, method name is same. Method name is same. Arguments are what? Also same. Arguments are also same. If I run this code, now see what error we are going to get. Okay, it says Balaji compiler method says, I mean compiler is saying it to me, method M1 int is already defined. Why you are defining it once again? Duplication has been identified. So by this, can I conclude that you cannot duplicate method signature? Yes or no? Can I have that conclusion? Come on guys, type something in chat box. Can we have that conclusion? Now can I have that conclusion? Can I have a duplication or not? You cannot have a method signature duplication. If you are having any method signature duplication, you get what? You get compile time error. Right? So the answer is note. Please be informed that you cannot duplicate the method signature inside the same class, and when you do so, you will get compile time error as follows. So this is the ideal program for the proof, right? And what is the compile time that we have got? It says it is already defined. Why are you defining it once again? Right? No matter what the return type is, it always look for what the method signature. Okay, are we good so far? Yes or no? Okay, I don't know. I'm not sure whether your answer is to my previous question or the current question. To this question, there is duplication. Okay, this is a duplication. This program is talking about method duplication. Previously, there was no duplication. Understood? Right? Now you see the next question is, okay, so far so good, sir. Everything is fine. So there is a method duplication. Now you tell me, okay, I am taking float j. Okay, let me take it as void only. Okay. Now tell me, how many method signatures are there? Don't ignore this main method. Apart from main method, how many method signatures are there here? How many method signatures do we have here? Come on, everyone. How many apart from main method? Okay, we have two method signature. Okay, instead of calling method signature, I can call you. I can also say there are two methods. Apart from main method, there are two methods, and each and every method has a method signature, and there is another method signature. Okay, is there any duplication here, or it is a non-duplicate method signature? Tell me. Duplication or no duplication? Do you think that both the method signatures are same? Hey guys, are you thinking that this method signature is equal to this method signature? Are they same or different? Come on, same or different? No duplication. Now why are you taking so much of time for this, guys? Come on, please focus, please focus. No duplication, they are different. Okay, different method signature. Now please focus here. Okay. With respect to method signature, I am giving the definition. With respect to method signature, if you find same method names, method name is same, m1, and with the method what we call it as the arguments are different. What did I just say? When you find same method names with difference in arguments, okay, these two methods are called as the overloaded methods. Let me repeat this for you once again. Okay, let me repeat this for you clearly. Okay, so we have some methods here. Okay. Please be informed that whenever you find methods with same names, this is one of the methods m1, this is another method m1, both methods are possessing same name, but there is a difference in the arguments. There is some difference in the arguments. Different argument. This method is accepting integer as an argument, this method is accepting float as an argument. Okay, when you have two methods name with different arguments, okay, you can call them as, these methods are called as what? The overloaded methods. They are called as what? They are called as overloaded methods. Right? Now go back to our definition. Okay. Please be informed that when you have two methods with same name and different in parameters or arguments, you can say, any word can be chosen, no issues, they are called as overloaded methods, and this is called as method overloading. We have completed what is method overloading. Go back to the Spain screen. Okay, what was the first first subcategory? Method overloading. What is a method overloading? When you find two methods with the same name but different in arguments, they are called as method overloading. Done. Method overloading part is done. What is its usage and what are the test cases? What is the case study that we are going to discuss? Now I hope you are able to understand what is a method overloading. Yes or no? Type something in the chat box, everyone. Are we good in understanding the concept method overloading? Okay, very simple. Okay, this method overloading is part of what? It is part of the compile time polymorphism. Why it is called as compile time polymorphism? Okay, why we need to call it as what? The compile time polymorphism. The next question is, you might be thinking, so far good, we are calling we know what is a method overloading. Okay, then reason why, okay, let me do it guys. Method overloading. Okay, this is method overloading. Okay, why it is called as compile time polymorphism? Okay, the method resolution will happen at the compilation time. Okay, people got confused, and again we need to discuss what is the method resolution and what does it mean to, why it is happening at the compilation time. I will explain this for you. The method resolution will happen at the compilation time, and that's why it is called as compile time polymorphism or static polymorphism. There are many words guys, or yearly binding. Okay, in the interview room, okay, sometimes they ask you, instead of what is method overloading, they ask you what is static polymorphism. or they ask you what is compile time polymorphism, or what they ask you what is early binding. Just to confuse you, all are same, all are one and the same, right? Now see, let us see some examples so that this compile time polymorphism will be clarified in after discussing few more examples. Okay, now you see guys, you see, let us go back to the program. This is our program. Okay, so I will keep the Eclipse editor open so that it will be easy for you to observe, because they are in colors, right? Okay, I will just keep it open for the future topics. Okay, meanwhile let me open this notepad. Now you see I have two methods. Okay, two methods. We do compilation and we do what? We do execution. Okay, and the compiler is going to create a method table which is going to store method signature, which has just been discussed. Okay, now you see I want to call the method. I want to do what? I want to do the method call. Okay, let us make it simple. Okay, this is one method. This is first method is no arg method. Second method is int arg method. Focus guys, it is going to be very interesting. Okay, this is int arg method. Okay, third one I want to take it as the let me take it as the double arg method. Float int double. Okay, if you observe one thing, you notice here one thing guys, I have three methods m1, m1, m1. All the methods are possessing the same name. They are assigned with the same name. Okay, the only difference is they are different in parameter. You take all the method signatures, they are different in nature. They are not same in nature. Okay, now can I conclude that these all three methods are overloaded methods? Just by the definition that we have just discussed, I can say that all these three methods are overloaded methods. Okay, now see the see the beauty of this concept, beauty of method overloading. Okay, I want to create an object for the test class. Okay, test obj equal to new test. Okay, test obj equal to new test. Okay, what has just happened? The object is going to be created. Yes or no? The object is going to be created. So by using this reference variable obj, okay, if I want to call this method, I can directly use the method name m1. Okay, I'm not supposed to pass any arguments. If I want to call this method, okay, this method is not accepting any arguments, empty arguments. So by this, don't you think that the output is going to be what? No arg will be displayed in the console. Yes or no? Yes or no? Likewise, if I want to call obj.m1, okay, method name is same. Okay, the behavior that we are going to choose depends upon the values that we are going to pass here. Right? If I want to call this method is accepting an argument of integer type. Okay, I need to ensure that yes, if I pass some integer value, here, this method will get executed. Yes or no? So I can pass integer value 100. You can pass any value, not only 100. You can pass 1000, you can pass 10,000, anything. Okay, for the first call I can pass this. For the second call I can pass 100. Okay, for third call I can pass 1. Okay, for all these three calls, for all these three method calls, don't you think that this method is the matching method and this is going to get executed? This int arg will be printed in the console for the 3 times. Yes or no? Int arg. Okay, int arg. Okay, int arg. Okay, this int arg is going to get displayed in the console for the 3 times. Why it is going to get displayed in the console for the 3 times? We are doing a method call that is m1, and this method we are passing a value which is of integer type. There is only one matching method which is accepting the value as integer type. This will get executed for 1 time, 2 time, 3 time. Okay, if I want to call this method obj dot m1, I need to pass a double value, a floating point value, 100.10. Okay, it will identify, the compiler will identify the method signature in the respective method table. Okay, it will find, okay, there is a matching method here, right? And this method block will get executed because this is the double value matching. Output is double or. Okay, according to this, don't you think that the output should be no or, int or, 3 times int or and 1 time double or? Yes or no? See, 1 time no or, 3 times int or, 1 time double or. This is called as what, guys? This is called as method overloading. This is called as method overloading. And you see one thing, always remember one thing here. Always remember one thing. Just keep one thing in mind. OBJ is of what type? Test type. OBJ is of what type? Test type. Okay. So all the method calls, we are doing some method calls. Okay. These method calls will already decided by the compiler in the compilation time. All these method calls will already be decided by the compiler in the compilation time itself. That's why it is called as what? The compile time polymorphism. Let me repeat this. I will also show you a program to prove my statement. Okay, why it is called as compile time polymorphism? Method resolution will happen in compilation time. Okay, so okay, see, this is the method calls. OBJs of test type. This will be decided by the compiler. Okay, there are few methods in the test class. Okay, the solution will be decided by the it won't wait till the runtime. So it is going to be decided by the compiler in the compilation time. Okay, all this object will be identified in the test class itself. It will not get identified in the runtime. Okay, it will not look this. It will always look the left hand side. Okay, compiler will decide. Compiler will come to know this. All this method are part of test class itself. There will be some cases. Okay, the left hand side part is going to be a different class. The right hand part object creation is going to be different class. Okay, the decision will be made by the compiler in the compilation time. That's why it is called as what? The compile time polymorphism. Right, one more example. See, now you see, guys, now you see, let me remove all this. Okay, now you tell me obj dot m1. Okay, I want to pass something like inside this. Let me pass Java. Okay, now what will I get? Any compilation error, or will one of this method will get executed? Tell me. You itself tell me. By looking at this program, can you guess the output? Is there any method signature like this? Is there any method name? Okay, there is a method name m1. Is there any parameter that is accepting string as a value? Is there any parameter here? Do we have? Yeah, do you agree with Chaitanya, everyone? Chaitanya says that because Chaitanya is under the impression that okay, we are passing a value which is Java. Java is of what type? Java is of string type. Okay, there is a method m1. It will check each and every method. Okay, this method is accepting double. Okay, it is not the right method, and this method is accepting integer. It is also not right the method, and this method is accepting nothing. This is also not right method. It has checked all the methods. We have cheated. It is not able to identify. Don't you think that compiler is going to scold me or not? You agree with Chaitanya, everyone? Respond, guys. I want answers from everyone. Very simple question. Jyoti and Sashwant, Ratna Kumar, Venkatesh, Samyukta, Sagar. It is going to be an error. See. I'm sorry, I want to save this code. See? No suitable method found for m1 string. Has scolded me nicely. See, so many words has been used against me. Okay, so in the method table, compiler will find is there any method signature of m1 string. Okay, it will try to find is there any method signature in the method table. There is no such signature. This resolution is happening in the compile time itself, right? Compiler, okay, when I am getting the error during the compilation time. Did I ever run this code? No. During the compilation time I'm getting this error because the resolution is happening in the compilation time. Why compilation time? It will try to check obj is of test type. Is there any method in the test that is accepting string as an argument? No, there is no such method. Okay, let us scold the programmer with these words. Are you getting this? So no matching has been found. Okay, now I will tell you one thing. I went to an interview to a company, and I got a question like this. I got a question like this. Okay, they asked me if I know the compile time polymorphism, and I said yes. They asked me what is the method overloading, right? I said some theory, blah 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 theory. Everyone will agree with the theory because theory is universal, right? Everyone will try to memorize the theory. Very this such thing, right? So they asked me, okay Balaji, your theory is so good, much appreciated, very good theory. Okay, and your method overriding is also good. The explanation is perfect. Can you answer this to me? Can you answer this question to me? Okay, if I run this code, what will be the output? This was the question asked by them. Okay, let me remove this code also. If I run this code, what is the output now? Okay, let me do this. Let me include this obj dot m1. Okay, very famous interview question for the certification. Okay, now you tell me. Okay, now just tell me this. Will I get any error for this code? Firstly, answer this to me. Will I get any error for this code? Yes. Or what is the output for this code? Come on. What is the output if I run this code? No arg is the output. Good, Chaitanya. No arg is the output because m1 method of no argument type will be executed. So m1 method of this instruction will be executed. Okay. Now, if I run this code, what is the output now? Why you don't need to think much, guys. I look for m1. Is there any method that is accepting integer as an argument? If it is there, that will get executed. If it is not, that will not get executed. According to my logic, which method is going to get executed? Do you think that it is going to get executed? Yes or no? Integer arg will be the output. Integer arg will be the output. Good, you are good. Okay, this is second example. Integer arg will be the output. Right? Now what is the output? Now I am passing the character data type, the value of the character data type as an argument. Now what is output? Will I get error like this? Will the compiler is going to scold me, or you will get any error? Come on, answer everyone. What about others? Are you getting my question? Have you got my question? If I do this, what is the output now? Previously, I did this. Previously, I did what? Java. What did I got? While doing this, what did I just got? For my previous example, I got this error. Blindly it has scolded me. Now, why it has scolded me? No suitable method was found. Yes or no? Same question I am asking in a different way. What is the output now? Response is errors. What about others? Any answer for this? Come on, I'm waiting for your answers, guys. Please. Naidu Sagar says error. What about Samyukta? Ratna said integer argument. Chaitanya, Krishna Prasad, Jyoti, and come on, any Chaitanya says integer argument. Okay, let me explain this for you. Okay, try to think here. Okay. Okay, so what happens? See, we have given a resolution. Okay, so this is a logic here. Object is getting created. First line, no issues. Second line, okay, just try to understand. The method table will be method signature table. Method table will be created by the compiler. Okay, for the test class. Okay, how many methods are there? There is m1 method that is accepting nothing. There is another m1 method that is accepting the integer as an argument. Right, these are the two methods that I have. The method table, these are the two signatures that the compiler is going to create and store the respective method signature, method table. Okay, what I am passing here? Okay, I am passing, I am using obj reference. Okay, I want to call method 1, but I am passing a value that is not even in the method table. I am passing a character value. I am passing a C is of character type. I am passing a character value. Is there any character, is there any method signature that is matching this? Do we have any method signature that is matching this? Do we have this method signature in the table? We don't have any method signature like this. But what value we are passing? We are passing a value like a character. Okay, first, okay, first the first it will identify for, is there any method m1, is there any m1 method that is accepting the character type? No such method, no such method. Okay, then it will try to do some promotion. It will try to do what? It will try to do some promotion. What kind of promotion? What kind of promotion? The data, the primitive data type promotion. Okay, we are passing a character variable. I have already shown you the data type chart, primitive data type chart. What is it? We have byte, right? Byte, we have short, we have integer, we have long. After long, we have float. After float, we have what? Double. Right? This is the chart for what? Primitive data type. And there is also a character. There is also a character. Char is going to be under what? Under integer. Right? So this is the table that we have. Right? Byte can be promoted to short. Short can be promoted to integer. Integer can be promoted to long. Long can be promoted to float. Float can be promoted to double. This is the chart. Okay. Now your compiler is identifying the character value. C is the character value. C is the character value. Okay, if it is not able to identify the respective method that is accepting the character as a value, it will try to promote. Okay, this is not found. Promotion will happen. Promotion has been happened to, character has been will be converted to integer. Now it will check, is there any method that is accepting integer as an argument? There is a method. According to the promotion chart, the promotion will happen and the respective data type parameter of the method is going to get executed. Integer is already there. Okay, the output is going to be what? Integer argument will be displayed in the console. There will be no error. Previously, why we got error, sir? Why we got error previously? Previously, we were passing obj dot m1. Okay, we are passing a value called Java. Okay, the Java is not even in this. The string. This is a string type. String is not even part of this primitive data type. So there is no kind of promotion. Nothing can be done. That's why we got error. But in this case, there is a chance of promotion. The the data, the value of the data that we are passing will be promoted to the next level, and it will try to find, is there any data type of integer? It is there. This will get executed according to the promotion chart. If I run this code, okay, no compilation error. So we got integer argument as an output. Okay, sir, this is good. This is somewhat good. Okay, let me take it as double. Okay, let me take this as integer I. Okay, now let me remove this integer j. Okay, integer type. Okay, this one is, let me take it as double type. If you get locked out of this meeting room, please rejoin. Double type. I want to pass C. I'm passing something called as C. Okay. I have integer, I have double, no C is here. I mean, no character type method is there, no matching method is found. If I run this code, what is the output now? Any idea? Anyone can help me with the answer? Or do we get int type or do we get double type? As a, what you will see in the console. Samyukta says int type, int type, int type. Okay, everyone are saying int type, int type. Why we are getting int type? Okay, int type. Why we are getting int type? So we are passing a value of character type. Very simple. Okay, we are passing something like a character value. Okay, according to the promotion chart. Okay, this is our promotion chart, isn't it? This is our promotion chart. Okay, we are passing character. Next to the character, next chart is integer. It will try to find a method that is accepting integer as an argument, integer as a parameter. There is a matching method, integer is there, so this will get executed. Now if I pass, instead of if I want to pass 100L, 100L is of what type? It is of long type. Long type. It is not even integer type, it is a long type. Now what will be the output now? I'm passing something like this data type is a long type. Which method get executed, or will I get any compilation error? Is there any possibility that the program will be unaffected, or will there be any kind of compilation error? Come on, help me. Do we get integer type, or do we get double type, or do we get an error? Suspense says error. What about others? You got my question? I'm passing a long value here. Long value here. Think and say. Think the promotion chart and say. Long value here. Is there any possibility for the promotion? Chetina says error. Okay, let me run this code. Okay, compilation is successful. What when compilation is successful, what is the answer? Double type. Why we are getting double type? Now you see we are passing a value long here. This is a long value. 100L is what? Long value. Go to the promotion chart. We are passing what? We are passing long. But long is not available in the program. Long data type is not available in the program. It will get promoted to what? Float. Float is available in our program. Float is also not available in the program. It will get promoted to double. Double is available in the program. Yes, double is available in the program. That's why double type. Agree? Agree, people who have said error? Are you agreeing? Is it making sense now? Yeah. Now you see. Now you see. If I want to pass what? If I want to pass, okay, let me take it as float. Okay, I am taking this as float, and I also taking this as float. Okay, and I am removing double. I am taking it as character. Okay, everyone are in. My screen is visible and my voice is audible, guys. Just quickly confirm this. Okay, okay. Now you see. So here I am taking the float type. Here I am taking the what type. Here I am taking the character type. Character type and float type, and this has to print what? Has to print character. Okay. Now I am passing. I am passing here 100 when 10.17. Okay. Now what will be displayed in the console? Think and answer. First you need to identify what value is being passed. Okay, then look for the respective method that is accepting the respective specific parameter that you are passing. Got my question? Everyone, are you getting my question? Float. What about others? Do you agree with Chaitanya? What about others? Come on, fast. Everyone are agreeing with Chaitanya? Is there any different answers that you have? Okay, okay. See, so we are passing the float. Okay, I trust you. I trust you. Okay, we will do the compilation. Do the compilation. See what we got. It's scolding us. See, always remember when you pass a floating value, okay, it's not always floating. Floating means you should specify it as f, mandatory. When you specify it as f, then you can call it as the float method. But what did I just do? When I pass a decimal, when I pass a value like this, when I representing a value like this, okay, with along with the decimal forms, decimal values, it always means it is double. Okay, now it will find is, the value is double. Okay, go back to here. Is there anything like double here? We have float, we have character, but we are passing what? We are passing the double type. Okay, we are passing what? We are passing the double type. Okay, go back to our this thing. We are directly passing double type. Is there anything next to double for the promotion? No, nothing is there. It can always promote like this. It can always go in this direction. I mean, from byte, it will always go in this direction. From character, it will always go in this direction. But it cannot come to the opposite direction. Reverse direction is not possible. That's why the direction is specified clearly. Okay, we are passing a value double. Okay, but there is no such signature double. We have float, we have character. Okay, now then it will try to do the promotion. It will try to do the promotion. After double, nothing is there. You cannot promote. Nothing is there. You can do deep, depromotion. Depromotion is there, but depromotion is not possible. Only promotion is possible. That's why we are getting an error. This is case one. Okay, this is our first case study with respect to the parameter, with respect to the values that we are passing in the method calls. Do you understand this case study? This is case study one. Case one. Okay, what does the case one says? Please be informed that if the right matching values are not passed in the method calls. If you are passing the right matching values in the method calls, no issues. If you are not passing the right matching values in the method calls, what does it really mean? What does it really mean? It will promote the data type accordingly from smaller type to the larger type. Right? And if the promotion is successful, if the data type promotion is successful, what happens if the data type promotion is successful? The respective method with respect to the data type will be called and executed. If not, you will get compile time error. Understood? Very simple. Go think this program. You might be passing character. Okay, if there is any method, okay, you might be passing a character, but if you are placing methods that is accepting float, that is accepting long, you are placing these two methods in the program, but you are passing the character. You are actually passing the character. Okay, what will it will do? It will not throw the error directly. It will promote integer, not there. Long is there, so this long method will be executed. Making sense? So this is the case study one. Like that, we have 4 to 5 cases to get some kind of empowerment in this overloading topic, right? So another case study is like, okay, I have let me redo this program. Okay, this is my code, this is case 2. Okay, focus here. So I am taking the case here as object O, object O, object O. Instead of float type, I want to take it as object type. Okay, and in this case, I am taking it as what? String S. Okay, and in this, I want to take it as what? String type. I want to take it as what type? I want to take it as string type. Okay, now you tell me. The object is created, already created. I do not want to make any changes here. On this object reference, I want to call m1 method. Okay, and I want to pass a value of string type. Java. What is output now? String type or object type? What is an output now? String type or object type? Come on. Why you are taking time, guys? M1 method, I am saying M1 method. Okay, I am passing Java. Java is string only, no? Matching method is there. Now, don't you think that the output is string type? Why you are taking a lot of time here? String type is the output. Why you are taking a lot of time? Output is string type. Okay, let me run this code. Java C space test dot Java, Java space test. String type is an output. We have no issues with the output. Okay, if I want to do what? If I want to do new object. Okay, I am passing a new object, a value, the reference value. I have created an object, I am passing new object. Okay, in this case, the output is going to be what? The object type, because new object is part of object type. So the output is obviously going to be object type. Okay, so there is some case here that you need to observe. So here we have no issues. Here the output is object type. Okay, now if I pass null here, right, now focus. If I pass null, okay, the value null is, okay, this is also an important interview question. Just focus here. The value null is matched completely to what? String, as well as this value null is also completely matched to object as well. Let me repeat. The value null is completely matched to string. String will also accept the value null. Likewise, this value null will also be accepted by the object class. When I run this, what will be the output? Okay, what really happens inside is, compiler is very clever than us. Compiler is designed in such a way that it is very clever to identify which method needs to be called. Okay, this is our method. Okay, now you remember, object class is the mother of all classes, right? The parent of all the classes. Under object class, you have many number of classes, including user defined class, including string buffer, thread. Many number of classes are there. Okay, one of the classes is string is also a child to object class. String is also a child to object class, right? And you are passing a value null here. You are passing a value what? Null. Null. Okay, compiler will not be having any confusion. Compiler will try to identify the matching method. It has found two matches. This null is applicable to object also. This null value is also applicable to string. It doesn't mean that it is going, since it has found two matches, it doesn't mean that it is going to execute all the two methods. Not that case. It will see which is the child class. It will give priority to the child class, not the parent class. Okay, among these two cases, one is object class, second one is string class. So far we have dealt with primitive data types. Now we are dealing with class types. We have object class, we have string class. These two classes are capable enough to accept the null value so that the respective method will get executed. But the problem is, this can accept null, this can also accept null. It doesn't mean that since both are accepting null, these two methods will get executed. It doesn't mean that. What actually happened behind the scenes is it will give priority to, okay, this chart will be created. It will try to check which one is the child class. Okay, string is the child class, of course. It will say a string, since you are the child class, okay, I want you to execute this. Okay, even string class is getting executed, don't you think that the output is going to be string type? If my explanation is correct, the output should be what? The string type. So this is the popular interview question. So there will be some times where the value that you are passing it here is going to match to the methods. Two methods will be, all the methods are going to be matched by the respective value that you are going to pass. In that case, it will try to create an hierarchy. Which one is parent, which one is child? It will tell child class, please go ahead with the execution. This will be given priority. That's why the output is what? The string type. Okay, this is what? This is case 2. Case 2. What does the case 2 say? This is a program. When you pass a value to the method arguments, which is going to match all the overloaded methods, then the child class of the respective type would be executed. I should say that when you pass a value of class type, not primitive type, of class type to the method arguments, okay, to do a method call, okay, which is going to match all the overloaded methods defined in the class, then the child class of the respective type would be executed. So among this object versus there will be a fight between object and string. They both will fight. They will come to a conclusion. Okay, child will be given priority. That's why output is true. Right? Are you getting this? This is the second case. Yes, no? Do you have any confusion here? Right? So like this, we have we have 4 such cases. Okay, we have completed 2 cases today. We have 4 more cases that I will introduce you tomorrow. With that, the concept of overloading is over. You can able to answer any type of questions on top of method overloading.